Welcome to Haxby Shed. I want to make a power feed for my tailstock. I'll need it for a future project I've got in mind. Not quite sure how to do it. Let's have a look at the options. On a lathe of this size and design, I think the best way is to fix the tailstock to the saddle so that as the saddle is driven along, it pulls the tailstock along. And I've seen this done a number of ways. And a common way is to actually put a strip at the front here on the tailstock and a strip here so that the two engage and then lock together. And it's kind of this sort of setup. So you move one behind the other and then the two are locked and then this pulls it along. But I don't want to be drilling into my castings. I want to do it some other way. I think my solution is going to involve using this threaded hole here at the front of the cross slide, and then some kind of strap that goes around all the way around the tailstock, and maybe with some adjustable positions on it. It would be ideal if I could rig up some kind of flat bar that ran all the way back in this gap under the tailstock and was fixed at the back. But that's not possible because of the clamping block for the tailstock is a great big block underneath here, and it would obstruct any bar coming through there. So for the tailstock, it's got to be perhaps a couple of parallel bars that run back like that, and then with a bar through it. But that means I've got to change the shape of it. So maybe a flat bar to here, spreading to the sides, two bars going along. And then it would need some support somewhere, so maybe it could rest partly on here and the opposite at this side. And then maybe behind the tailstock it could rest on the top of these V-ways. It's a bit difficult to know how it would all settle and whether or not I could get the thing on and off easily enough. So I need to make a prototype. I'm going to have a look in my wood store and see if I've got enough wood around of the right shape to make up some kind of prototype from that to start with. And then I'll order the metal from eBay and fabricate the shape that I need, if I can get this to work. In Haxby Shed, how long does a plan last? Not very long, I can tell you. Just look at that clamping block on the underside of the tailstock there. If I just move in, you can see that some of that metal is not required. On the top face of that block, I could take some metal off either side of where the bolt goes through. And then I could have a flat bar which was forked, and that would slide either side of that bolt, come to the back of the tailstock, and then be have a peg through of some kind. And the flat bar, with like a tuning fork shape, would rest on the top of that block. So although I'm not prepared to drill and tap castings, I'd be quite happy to take a bit off that block. And because it's a direct pull, my flat bar doesn't have to be all that thick. 6 or 8 mil, something like that. Now that would be a very simple solution, wouldn't it? Now sometimes when the tailstock has got something heavy in it, it tips sort of front forward. But pulling at this level, right down there, would stop that sort of tipping action when it was being dragged along. So I think that's my preferred solution now. And actually I don't need to build a prototype for that because it's just a long length of bar really. I think we might have something there. This is showing where I'm planning to fix to at the front, where I would put the screw in. And that is the fixing position for the travelling steady. Now, strictly speaking, it's the body of the saddle and not the cross slide. I need to measure the size of the bolt on the tailstock clamp. I know it's going to be imperial, so 1/2 inch. I'll call it 13mm for these purposes. One thing that surprises me is how much of a slot there is in that clamping block, because I can't imagine any situation where that would have to slide so much. Bit of a mystery that. There might be a reason that I just haven't discovered yet. That screw looks pretty central within the block, doesn't it? So let's see what we've got. This is looking down on the bed. Flat way, V-way, gap, flat way, V-way. So there's a 44mm spacing there. And then if we look at the clamping nut for the tailstock, here, 13mm screw. So 44 minus 13 divided by 2, 15.5 for 2 flat bars going in there. Maybe 15 each, allowing a bit of clearance. And then if I look at the bed end on, V-way, flat way, the depth of this flat way is 15mm. So it's kind of saying a maximum of 15 by 15 square, but I wouldn't use up a depth of 15 there. But I need to go and scratch my head about that and work out what size of bar to use. Maybe 8 by 15, something like that. So now we need to look at lengths. The shortest length that I need would be when the tailstock is right up close to the saddle like that. But I want some flexibility. I can't see into the future. I don't know. There might be situations where the saddle needs to be further, across than the tailstock. I can't think what that would be right now, but it's going to happen at some point, I'm sure. So maybe something like that would be my maximum, maybe that even. So I'll just measure those off. I don't think there's any harm if the pulling bar is a bit long. It can still stick out from the end of the bed, if need be. And if it was too long, I can just cut it shorter anyway. I'll measure up at that. This is my design for the drawbar then. This section here would sit underneath the saddle, 160 long, 40 wide, 8 deep, and then 2 strips coming off that, 300 long, 15 wide, 8 deep. So that's my ideal design. I need to look on eBay now and see what I can get, and perhaps go for the nearest to this that I can find. I'll get that ordered up now. How can the sky be this blue? The early part of the spring was really cold, but it seems to have warmed up a bit now. I often say that noise is the enemy of video. I finally bought myself some decent workshop boots with steel toe cap protection, because I've nearly dropped the four-jaw on my toes a number of times. But listen, I'm going to have to get those greased. I've no idea how much force you get on the tailstock. It's quite a small hand wheel, but I'm going to try and measure the force at this point when this wheel is turned tight. So as I was bringing these scales out, she said, oh, it doesn't matter if you get oil on them, and if you break them, that's fine. Well, it was something like that, she said. I can't remember exactly. But it's all in the name of science anyway. This is the rig. Turn the hand wheel, measure the pressure on the scales. Now these scales measure up to 20 stone, so I'll explain that later in pounds and kilos. 6 stone, 8 stone, 11 stone. Now this wheel's getting pretty tight by now. 16 stone, 17. Coming up on 20 stones. Oh, it looks like it's more than 20. Oh, the scales measure more than 20. Oh, 22. Well, I'm putting quite a lot of force on that wheel by then. You know, it's about as much as I would want to put on drilling into something, really. Let me explain our readings in the various ways. 1 pound is 0.454 kilos. 1 stone is 14 pounds, which is 6.356 kilos. Now I measured up to 22 stone pressure on these scales. But I think, you know, let's add a bit to that and say 30 stone would be a reasonable, normal maximum pressure, which is 420 pounds, which is 190 kilos. Now in an imperial ton, there's 160 stones. So 30 over 160 gives us 0.1875 of an imperial ton. Now I'm saying there an imperial ton because an imperial ton has 2,240 pounds and an American ton has 2,000 pounds, which are both different from a metric tonne. Anyway, the point is you can see that on any drawbar system that I'm using to pull forward the tailstock to give it a power feed, the amount of loading on that drawbar is really going to be minimal, normally speaking. Probably not normally more than 0.1875 tonne. Now I've kept this in tonnes because in my mind I know that mild steel has a tensile strength before it starts to stretch of about 28 tonnes per square inch. And that feels natural to me because I know roughly a modern car is going to be about 1.5 tons, here anyway. So I can visualise that. In the other systems I can't visualise it. Let's have a look at how much load my design can take. This is my material for the draw straps. 30mm by 8mm. And what I'll do is cut it down here to make 2 draw straps, approximately 15 wide each. So I've drawn this here, 15 by 8. If I have a 5mm screw, I'll have this area here times 4 across the 2 straps. So to do this in inches, the area of this, 5 over 25.4, 8 over 25.4 times 4, which is this times this times this, equals 1/4 of a square inch. Now if my strength of the material is 28 tons per square inch, 1/4 times 28 gives me a strength of the system of 7 tons before it starts to stretch and deform and whatever. Now I think my maximum practical load is 30 stones, so 30 over 160 stones in an imperial ton over 7 gives me a safety margin of 37, which should be enough. And then the other consideration is the shear strength of this 5mm screw. Well, I'm not even going to work it out because it's certainly more than 30 stones, times 2 screws of course. So structurally and strength wise then this design looks sound. One question might be, you know, would this be a bit too floppy if it's cut into these sections and it's quite long like this? But we'll see, won't we? One step at a time. I think I'm confident enough now to cut this down the middle. Might be a manual hacksaw job that, unfortunately. About 1.25 inches left to go. What's that? About 32mm, I suppose. A bit of stress relief coming out there. Hopefully I can straighten that on the press. Let's see if I can get these something like straight. Just give them a little squeeze. This is one of those occasions where I really do feel I could do with a milling machine and a nice magnetic table. But, you know, you've got to work with what you've got. Well, those have come out all right. Stupidity cost me one gouge just there, but nobody will notice that where this is going. And if you're wondering why did I go to so much trouble to produce these, well, it's because I couldn't buy this as a stock size. I could get 16 by 8, and actually these are finished at 14 by 8, which is just right for what I want. So I went for this solution. Get a 30, cut it in half machine. This is the plate that I'm going to use for the front part of the drawbar. It's 40mm by 8. Looking at that measurement there to the top of here from the flatway is about 30mm. This can pass under the front of the tailstock by 15mm, and that's all. So I don't want this sticking out more than 15mm over this edge here. So that tells me where I need to cut this. So I'll put that underneath now, scribe at the front, cut that part off. That part will then become the vertical and a little bit more, so I can also weld on the underside. It's a 3/8 screw in the front of the saddle, so I'll use a 9.5mm drill for clearance. Well, that seems to have gone pretty well, so the next thing I need to do is to weld on this underplate, which will run under here, and get it square. I'm holding that together with a magnetic clamp, so I'll put a couple of spot welds on it first and then make sure it's all true before I weld it properly. I'm still on the lookout for my TIG and MMA welder. I said in a previous video that I was thinking about buying a TIG welder, and many people on the channel have encouraged me to do that, so I'm now doing the background research. I've pretty much decided I will buy one. A lot better than this old orange tin can I've got there, which I bought in about 1980. I can weld with it, and if that will focus, there you go. This side's not too bad, but this side, see the bit of a grind there? I'm looking forward to trying a DC welder, a modern welder. I think they've come on a bit since that tin box there. Well, that's with the plate on. Let's look at it from the other side and see if it's laying square. Well, that seems to have come through all right. This side is level with this flatway, and it does sit level at both sides. It's not like that or like that. When I look at this clamping block off the tailstock, it's had quite a lot removed. And I don't really want to take 14 by 8 off each side of this. So I'm going to make another. There we go. I'm going to make it out of this block. I can have a snooze while this cuts. Well done, Rapido. That's the first time I've used brake cleaner as a lubricant, because if I put oil on it, it wouldn't cut into it at all, it just skidded across the top. These block offcuts that I bought have proved to be really useful. Nice. I'm just going to centre drill this, then pilot drill it, and then finish it with a 14. That's done. It's more symmetrical than the old block was. I may have to machine some off here yet. I'm going to have to test fit it to find out. I actually remembered to put the table leg down this time. I'm hopeless at forgetting that. But with that down, it was cutting a mil off that tough metal without any problem at all. Well, I've just done a test fit, but I had forgotten about this cutaway in the bottom of this block. So what I'm going to do is use this eBay find, which I thought, oh, I'll never use that, and see if I can counterbore it with that. Well, it is cutting slowly, but there's just not enough rigidity in this setup. So having failed at counterboring, I'm now going to be lathe boring. Well, that's done. Arguably not the right tool, but it did the trick. 3.5mm recess, same as the cutaway in the other block. Well, they're going okay now. Maybe a mil or a bit more of vertical clearance, but the point is that the clamping block will support them if I need it. So the next stage is to weld those two rails onto the front plate which runs underneath the carriage. I'm just putting a bevel on the end of these rods so I can get some weld in. Really, it shouldn't be like this because the tool could catch behind this and tip it over, but I can't get it the other side, so I've just had to make sure it was tight in the vise. I've got the parts clamped to the bench. I've got a piece of 14mm bar spacing these two. I've got this rule along here and I'm sighting along this gap, and these seem to be in line. So I'll do a tack. This might bend like a banana as the weld cools, but I'll try and keep it even. Well, that's not looking too bad for a start. Seems to be straight. It's splayed slightly, but only slightly. Let's try it on the bed and see what it looks like. I've only done one side, I haven't done this side yet. Well, it's not bad. Let's see if I can get it under the tailstock now. God, these boots. There we are. Do you know, I think this is going to be a runner. Carry on. I think that's clamped up flat and true, so I'll now put the fillets in here on this side, and I can really build it up on this side, whereas the other side needs to be flat so that it can slide under the tailstock here. There we are. Hopefully it won't banana too much when I unclamp it. I think that's okay. I've had an idea to make a clamp. Now, it couldn't clamp the bed because obviously then these rails wouldn't be able to move. But with a bit of clearance, it could have something in between here, and with a clamp at the top, it might be that I don't have to drill these. Don't know yet, we'll just see how it evolves. I'll machine this and come back. I've done a fair bit of work off camera. Hopefully you can see that. Shaped it on the shaper. So these go in here. If I can get it on, there we are. And then that forms a clamp. Now I haven't finished it yet, but I might break my rule and actually drill and tap into this. A hole here, tap through. And this block could stay on the back all the time then. Yeah, I think that's taking some sort of shape. Well, it works anyway. Well, I've still got a little bit of finishing work to do, but as you saw, basically it works. It would be nice if the tailstock moved out as the saddle moved back, but that's just a couple of screws. So I hope that was useful to you. Thank you for watching Hagsby Shed.